Hi, everyone. This is to review some of the steps in calculating correlations, which are in Chapter 11. So this is the example of computational problem number 1 in Chapter 11, and I'm going to show you how to do the Pearson and the Spearman correlation for this data set. So the problem that we have here basically is your data set is looking at, is there a relationship between self-related health and the number of physician visits each year? So if you look at our variables, this is just the ID number of the participants. This is a self-related health. And so our values here, they only gave us value 1 and 5. I filled in kind of what we thought the others might be. But this values 1 through 5 is how people were asked to rate their self-related health. So that's on the ordinal scale. And then this third variable is how many physicians visit per year. That would just be a number that they would put in. So I don't need to enter any values. And then that would be a scaled variable. So here is all the data that was provided in the problem. So the ID number, self-related health, and how many physician visits a year. So our question is, what's the relationship between self-related health scores and the number of visits? And if we were creating a null hypothesis, it would be that there is no relationship between self-related health visits and number of physician visits per year. And our alternative hypothesis would be that there is a relationship between the two. And so we can use the Pearson or the Spearman, depending on whether your data is normally distributed. I'm just going to show you both in this data set here. And so you can calculate that relationship. So we're calculating a correlation. So sometimes what we'll do first in this is you can graph out your data. There's only 12 participants in this study, so doing a scatter plot with this data isn't quite as good as if you had a lot of data, but I'm just going to choose a simple scatter plot. And then I'm going to put in my values into the X and Y axis. It really, doesn't matter which one. And then you can see here on this scatter plot that it looks like the number of physician visits relates to lower related health. And so you can kind of see, if we were to draw a line through there, sort of what direction that would be going. So that gives us an idea of our data set. To do the analysis, you're going to go to Analyze, and you are going to go to Correlate and Bivariate. So this box pops up. You're going to move your two variables of self-rated health and physician visits over to our variables box. You're going to click the Pearson and the Spearman because we're going to calculate both of those. You want to make sure that two-tailed is checked here. And then in the options, you can put means and standard deviations, so we can sort of see that. So we hit OK, and this is what we get. So we get some descriptive statistics. So for our self-related health values, the mean value is 3.33 with a standard deviation of 1.23. We had 12 participants. The mean is 3.5, and standard deviation for physician visits and the standard deviation is 1.31. So those are just some of your descriptive statistics. Now, if we're looking at correlation, so this first box here is your Pearson correlation. And so when you read this box, you can see the self-related health here, as it correlates with self-related health. That is always going to be a 1 because you're correlating with itself. So it has the same values. The self-related health compared to how many physicians visits per year is negative 0.674. So that is your correlation. That's what your R equals. And so it is a negative correlation. And remember that 1 is the strongest correlation and 0 is the weakest correlation. So you're in a moderate correlation. Here is your significance. So the significance is 0.016. And so that is significant because it's less than our set alpha level of 0.05. And so when you write up your results, this is where your p-value is 0.016, or if you're rounding, you could do 0.002. And then this is the number of the number that were intersected. So you had 12 data sets. So that's fairly simple to read and to write up. Seeing this is remembering that this is your R, the correlation, and how to interpret that. And then the second part is your non-parametric version. So there are no descriptive statistics, but you can read the box the same way, read this output the same way. The correlation between health and our physician visits per year is negative 0.757. So again, a negative correlation. And then you also get the same thing down here. Your significance is 0.004, which is also significant based on our alpha level that we set for this. So whether you're doing the Pearson or the Spearman, you write them up very similar. So let me share with you how you might write up the answer to this, or put it into a report. So let's say we're talking about the Spearman. Spearman's rank correlation was computed to assess the relationship between self-related health and the number of visits to the physician. There was and so it's either negative or positive. So for this one, it was negative correlation between the two variables. Our R equals, and then in this box is degrees of freedom, which basically you calculate by how many were in your sample minus 2 variables. So that n equals, and then you're going to put in the R value here. So the R value for this Spearman is negative 0.757. And then the P value for this Spearman is P equals 0.004. So that's how you would write up sort of the result. And so really what this means is that these two variables are negative. There's a negative relationship. So as one would decrease, the other would also decrease.